Okay, so let's get started. So I'm going to do the lectures for Matthew for today and Wednesday. So today I'm actually going to review, he actually requested I should review, there's a concept called visibility for your like packages or projects. You either use public or private. I'm going to demonstrate that to you. It's actually quite an easy concept. I'll use some example to show you. And then I'm going to go on for JUnit tests. For those of you who already started lab number 1, you have seen JUnit tests already. But I would like to talk in a more systematic way. Why are we using JUnits? And how should you write the test methods? And how should you run? Stuff like that. Hopefully I can finish the 2 things today. If not, I'll carry on from Wednesday. Let me just show you one thing just before I forget. I'm going to post the recording of my lecture together with all the slideshow, voice, and also usually I do illustration on my iPad. So I'll make it available together with my students in the other section. So what you got to do is just go to, go to the course website for the CSE department. So if you go there, for now, just please go to 2030A. So that's, yes, 2030A. So that's the section I'm in. Go there. You will see at the end something about lecture materials. So if you go there, you will see the recordings. So these are the recordings I've done so far, but I'm going to add them in for today. Okay? I will try to send you guys an email once I'm done with that. Okay. So now I would like to start with reviewing the visibility for attributes and methods and also classes in Java by using certain keywords. And the 2 keywords we have to learn is one is private, the other one is public. So we should really know what they really mean. Okay. So now, first of all, just to make sure you know how to create the packages in Java. Okay, so we know that for your Java projects, it consists of a list of classes. And let's just, for example, you can reproduce this one very easily. Let's say I have one project with 6 classes. I'm going to read it out to you just in case it's too small for you. We have cat, we have chair, we have circle, we have desk, we have dog, and we have square. You can see somehow I put every class at the same level. That's okay, but it's not really the best way to organize your Java classes, just like in your file system. You wouldn't store everything, every file on the desktop, would you? Right? You'd rather create some folders or subfolders to organize your files. The same idea over here. So what you can do instead, for example, you can see cat and dog. They kind of belong to the concept of animal. You have chair and desk. They belong to the concept of furniture. So that's why you can create different packages. So what you can do is you can create a package called animal, another one furniture, and another one shape. You can move the classes into the relevant packages. You guys know how to create packages in Java? You're okay, right? Okay, let me skip this step. Okay, let's assume we have this package structure already. So we got one project, which is simply called collection of stuffs over here. And we got 3 packages, animal, furniture, and shape. Now I want to illustrate to you about visibility. So that's kind of the structure, project, packages, and we got classes, right? Let's say this is what we have. Now, let's first talk about, so when we talk about visibility in Java, you can either talk about the visibility for classes, or you can talk about the visibility for attributes and methods. I'll talk about classes first, and then move on to the attributes and methods. For classes, it's actually quite easy. There are only 2 possible visibilities you might have for Java classes. Either it is public or it is not public. But what does it really mean when it is not public? Okay, I'm going to show you. I will show you some illustration visually, and then I will show you on Java. And also the source code is available. You can also download it from the section website. Okay, if you want to declare the visibility for classes, there's only one modifier you may choose to use, which is called public. Okay, so you cannot use private. You cannot say private class foo. You cannot do that. It's disallowed. So only one. Okay, in some way that makes it easier. Okay, so you cannot say private class chair, for example. You cannot do that. So now let's see how we can declare the visibility of a class. Basically, it's about if I want to use a class in my projects, depending on its visibility, I may or may not be able to use it. Okay, let's see. So now you can say the more restrictive version of visibility is I want to say this class is only visible within the same package. That's it. If you go outside the current package, it's not visible anymore. In this case, you simply don't put public, just no modifier. For example, you might say class chair. Okay, that's one possibility. And the second one, let's say I want this class to be visible across the packages, across any class inside this current projects. In that case, I can use public. Okay? In that case, for example, you can see the difference. Now I just add public to the front of class over here. Okay? So we only got two possibilities here. Let's see some visuals to really convince you. Okay? Let's say this. So that's the more restrictive version. Let's say for chair class, I simply say class chair. I didn't put any public before that. In this case, that means only classes in the same package as the chair can get access to it. That's why you can see the yellow, kind of a scope. It's only within this furniture package. If I go outside, let's say, at the moment, can I access the chair from the cat? No, I cannot, because they belong to different packages. Okay? And also similarly, I cannot access to chair from square, because that's another package. But I absolutely can try to access the chair from the desk, because they are from the same package. Is it clear? Okay? Now, in the case where if I put public in front of the class, I say public, class, and chair. In this case, I'm not restricting at all, like who can actually access the chair class. The class is within the same package? Yes. What about the classes outside the current package? Yes, that's also fine. Okay? So let me just show you how you can see the sample code. I'll show you that very quickly. So you can, again, go to the website I just talked to you about. So I'm going to show you how you can download the example. I'm going to show that to you. If you go to that lectures webpage over there, so if you simply just go to the table here, there is a zip file called archive project file in Java called visibility. You can just download it, and then I'll show you how you can use it. Okay, I'm going to show you now. Okay, so now assuming that I have already downloaded the visibility projects on the desktop, so that's a visibility.zip. Okay, let me show you how you can use it. Okay, and then we'll see the examples. So now let me launch the Eclipse, and let me also create a workspace from scratch on the desktop in just a moment. Okay, let me just create on the desktop. New folder, let me just call that workspace. Okay, just that on the desktop. Just from, it's clean. So I just need to browse to that particular workspace. I go to desktop, workspace, and then I can say open. Okay, and then launch. Well, that's how you play with Eclipse, right? So hopefully that's not too strange to you. Okay, so once we got there, we're gonna just import the visibility.zip. So there's no, you don't need to type anything. Okay, you can just say, I don't want to see that anymore, and then close the welcome. So how do you import the packages? You can go to File, and go to Import. And over here, you gotta type EX. So I want some existing projects into the workspace. Okay, go to Next. And now, rather than this option here by default, you're gonna choose the one to say, I wanna select some archive file. As I said, archive file means zip file. And then you can say Browse. And now I can go to my desktop and select the one I just downloaded, visibility.zip. Choose that. It shows you we got quite a number of projects already in the zip, which is good because you don't have to retype anything. Once you import, you just get exactly what I want to give to you. And finish. Okay, so that's the 5 projects. Don't worry about if I got any problems there. That's actually intended. That's intentional. So I'm going to show you 5 different versions of the collection of stuff projects to illustrate to you. Depending on the visibility modifier you use, either public or later on private, it's going to affect whether your project will compile or not. The first one I would like to show you is, so it's called the visibility example 1. I'm going to show you what does it really mean when a class is only visible within the package level. Okay, that's number 1. So I want you to first go to the chair class. So we're going to modify the chair class for illustration. If you click on chair, you can see that at the moment, okay, is it okay? Is it too small? It's okay? Should I make it a little bit larger? Colors and fonts, and then you can go to Java here. Let me make it bigger. Apply. Okay, much better. Okay, so now you can see under the package furniture, we have this class called chair. I only declare the class as without the public. So that means only the classes in the same package furniture can get access to it. Outside this package, no, there's no way. You can also read the comments once you download the source code. I'm not gonna read it. So I want to show you, first of all, if you go to the shape package, which is different, if you go there, you can see there's a class called square. So now, how do I say I want to use a particular class? In Java, you simply say import. I want to import this particular class for me to use. Now, if I try outside the furniture package, if I say import furniture.chair, it wouldn't compile. If you hover your mouse over the red line over there, it says the furniture.chair class is not visible. So that should make sense, because we only declare the chair to be visible up to the package level, not across the packages. Okay, that's why. How do we fix it? Let's say if we want a square to get access to it. Well, just change the decoration for the chair. Go back to the package explorer here. Now let's go to version number 2, example 2. If you go there, and you can see under furniture over here, you can see how we have changed the chair. We add public. So now every class in this particular project, doesn't matter if they're in the same package or not, they can access this particular chair because it's public. So far clear? Okay. So now that's about the visibility for classes using just public or non-public. Now we're going to talk about how can we make either attributes or methods as either public, private, or no modifier. So you can see it's just one more complexity over there. So it's either public, private, or no modifier. But the idea is very similar. Okay? Let's just go over some slides, some visuals, and then I'll show you in the code. Okay? And then we're done with this topic. Okay. So now let's talk about how we can play with the visibility for attributes and methods. Okay? So you know that attributes are data. It's simply like an integer I. But if you have methods, it can be either mutator or accessor, right? You might return something or does not return anything. So, but the way we define the visibility for attributes and methods, they are the same. Okay, so I'm going to talk about them together. So there are two modifiers you can use, either public or private. So private is kind of the new keyword in this context here. First of all, let's just read this here. So now, the most restrictive visibility you can declare is simply private, which means this particular attributes or methods is only accessible within its resident class. If you go outside the class, no. If you go outside the package, no. So that's the most restrictive version. For example, you might declare an attribute, say private static integer I. So far, we talk about utility classes because everything is static, right? So I just use some utility attributes and methods. You put private before that. Also, you can put private static void m. So just another method, which is private. You can only get access to these two things within the current class. Once you go outside the class, no, you cannot do it. What about the next level? This option here is no modifier. When you say no modifier, it's consistent with how we talk about the visibility of classes. When there's no modifier for the attributes or methods, that means they are accessible within the resident package. Any class, as long as they're in the same package, they can access these attributes or methods. If you go outside the package, you cannot. Okay? So, for example, you might just say static integer I. You can see no private, no public. Also, you can declare the methods also without any modifier. over here, okay, without any modifier. What if I want the attributes and methods to be visible across the universe of the projects? Every class inside my projects should be able to access them. In this case, you just use public. Okay? So these are the three possible cases for visibility for either attributes or methods. Okay? Let's see some visuals to really convince you how they work, and then I'll show you the code example very quickly. Okay, now this is the most restrictive. Let's say for attribute I, method M, I declare them as private. That means only that particular resident class, which is chair, can get access to it. You can see, so their scope is only within this class. What about desk? They are in the same resident package. No, because they are private. What about circle? Of course not, because it even belongs to a different package. Okay, that's the most restrictive form. Next one. What about I want to make it slightly relaxing? In this case, I can take out the private, but I didn't add any public, just no modifier. In this case, I say for this particular class, I have attribute I and method M, no modifier. So that means any class, as long as they are within this particular package here, you can get access to it, right? That's why you can see the scope is what's shaded in yellow. What about cat? No, because that's in a different package. What about square? Also no, because that's outside that package. Now, for the least restrictive way to do it would be you simply just do public. If I say in the chair class, if I declare I and M to be public, that means every class across the packages can actually access this particular attribute or method. Okay? Any questions about this before I show you the code example very quickly? Again, we're going to play with the visibility of attributes and methods and see how they may affect the way you access them. Okay. Guys, questions? No? Yes? It's a good question. So the question was, are we going to cover the protected keyword? Not for now. Because usually when you talk about protected keyword, you talk about inheritance. We wouldn't cover inheritance until the very late point of the class. So don't worry about it for now. For now, you just have to understand private and public, or no modifier at all. Okay, let's just go back to Eclipse. I just want to show you very quickly how you're supposed to interpret the projects that you import. Okay, let's go back there to the package explorer. So now we have just seen number 1, number 2. Let's go to number 3. If you read its name, it says class level attribute and method, which means the attribute and method are going to be private. So they're only visible within their resident class. And let me show you. Again, we have the same package structure. Go to chair first. If you go to the chair class over here, you can see I is private, M is also private. So you can only get access to this attribute and method within the same class. For example, so this is a method called chair method within the same class. In this case, I can certainly make use of I can also make use of M, right? And also for the static attribute method, if you're in the same class, you can simply just refer to I, M as M. If you go outside, you have to use a class name dot, the attribute and the method, right? I'm pretty sure Matthew covered that already. Okay, I just show you some alternative over here. Since we're in the same class, you can actually call the attributes or method without the class name. That's fine. Okay, so now these two private things over here are only accessible within this class. If outside this class here, doesn't matter if that's in the same package or not, you're gonna have some errors. Let's go back to Package Explorer here. For example, desk. Desk in the same package. You can see in the desk, we are trying to say chair the I. No, you cannot do it because they're private. If you move your mouse over, it's gonna tell you chair the I is not visible. Okay? Similarly, let's say if you even go outside the resident package called furniture, right? So if you go to shape, for example, let's say in the square class, I'm trying to use chair.I. Also not possible because they're private. They're only restricted to their resident class, which is chair. Any question about this example here, right? So that's the most restrictive version. Let's now go back to version number 4. I want to relax the restriction a little bit, so I want the classes within the same package also be able to access them. Let me go there. So I will go there and then let's see, let's go to furniture again. If you go to chair over there, you will see now you can see there's no private, no public. You can see for method n, no private, no public, right? So just if you do that, that means only the classes within this current class and also within the current package furniture, they can get access to them. Okay? So that's why it will be okay if you say chair.i, also chair.n in the same class, that will be okay. Now let's say we go to the other package is outside. If you go to square, in this case, you can see we still cannot do chair.i or chair.n because square is outside that resident package, which is furniture, right? It's outside, so that's not good. How can we make this work? Public, exactly. So we can just create a version number 5 to add public in front of both the attribute and the method, and that will work. Okay, just confirm that together, and then we're done for this example. So now in version number 5, if you go to furniture package there, if you go to chair, now you can see that we added public in front of both attribute and method, right? So now this time you can just verify that yourself. Both the classes in the same package or in a different package, as long as they are in the same projects, you can access these two public attributes and methods without any trouble. Okay, any questions about visibility? So we talk about visibility for classes, we talk about visibility for attributes and methods. So they are two separate issues, but they are somehow consistent. Any questions? So can I say to Matthew that you guys understand private, public very well? I can say that, right? Good. Very good. Okay, so all the slides, all the source code is on their website, so you can just go there and download, just to play that with yourself. Okay, so now I would like to start a new topic for you guys. You have seen some of them already, like a JUnit test, but I would like to show you from a more systematic point of view, just to see why are we doing JUnits, okay? Okay. So the reason that we are doing JUnits is because it can allow us to do something called unit testing and regression testing. So here, let me just briefly explain what unit testing and regression testing are before we go on to the details. Unit testing means as soon as I'm done with a method in a class, I can start testing the method. For example, one of the lab example you did was to calculate the average, right, of 3 numbers. As soon as you're done with that particular method, you can start testing. So the most basic units in Java is called method, right? As soon as you're done with a method, you can start testing it. So that's called unit testing. Testing the small units. You should really test your code as soon as possible. What about regression testing? Regression testing simply means somehow you don't really want to just manually type your test every time from the console. I'll demonstrate it to you in just a moment. What you want to do is, because your software project is really subject to lots of revisions before it can be delivered. So every time if you make a change to your software projects, you want to make sure you can rerun all the tests that really passed previously and make sure they still passed. Because if there's any test case that actually passed before but it actually fails now, that means something bad happened that was introduced by the change you just made. Right? I'll illustrate to you, all the concept. And the reason that we are learning JUnits for this course is we're learning Java. But if you really work in the industry later, you may actually work in C#, C++, or even C. And they also got their own unit testing or regression testing framework, but the ideas are really transferable between the languages. So learning one should be sufficient to get an idea. Okay, so let's now go over some slides and then we'll see. Okay, so let's learn the JUnit testing using an example, a very simple example. Let's say we have a utility class. It's called utility class because everything is static. So we have two constants. You can see we have final static int, maximum counter value 3. And we got final static int, minimum counter value 0. So somehow we want to maintain a counter value, and the value should be between 0 and 3. It can be 0, can be 1, can be 2, can be 3. It cannot go below, it cannot go above. Okay? And then we're going to have more code in a moment. And we're going to see how we can throw exceptions when you're trying to update a counter such that you will go above or below the bounds. Okay? So now just a review about how you can refer to the value. That was easy. Okay, we also got two constants. And also, let's say we initialize the counter value to be its minimum value. Start with 0. Okay? So now, okay, I'll do the illustration in just a moment. Okay, there's only one single requirement you have to fulfill for this particular problem. You want to make sure every time when you're trying to change the value for the counter, for example, either to increments or to decrements, you want to make sure the resulting value you're trying to get into cannot be below the minimum, and it cannot be above the maximum either. Okay, that's a requirement. Okay. When you go to 3311 later, software design, it's something called invariance, but you'll get there later. Okay, that's a requirement we're trying to impose. Okay, you also talk about how you can encode precondition exception, right? Right? So let's say, in this case, we actually got two kinds of precondition violation, two kinds, okay? So now, okay, let's consider two possible scenarios where we might have some precondition violations. The first one is, let's say you're trying to increment the counter. Let's say if the current value of the counter is 3, and you're trying to say, I would like to increment its value. If I allow you to do that, what will be the resulting value? It'll be 4, in which case 4 is strictly larger than the maximum, which is not allowed, right? So that should be a precondition violation, okay? Similarly, the second kind is similar. Let's say when you are trying to decrement the value of the counter, let's say if the current value for the counter is 0, if I allow you to decrement that one less, that'll be -1, which is less than the minimum value. So that's also a violation. Okay? So these are the two possible scenarios where things might go wrong. When things go wrong, we would like to throw some exception to say you violate the preconditions for the counter. Okay. Okay. So now I'm going to encode those exceptions into the counter methods. Okay. So also the source code is available to you. In case you want to look at that, I'll show you very quickly where you should go. Again, you go to the course webpage over there. There is a zip file there called testing utility classes. That's the one you can go to and download. Okay, I'm gonna do that in just a moment. I want to show you something on the board on the slide first before I go there. Okay, you can just download this source code here. Okay. Okay, let's see what else. So now, how do we encode the precondition violation in the method? First of all, let's say we have a method called increments. Okay, and the increment does something very easy, just I++ or counter ++, right? Just want to increment the value by 1. But before we can do that increments, we want to make sure the current value is not too large. Otherwise, it might just go above the maximum. So that's why we said if the current value is counter the max counter value, which is 3, in that case we cannot do increments. Okay. Let me ask you a question here. Okay, and you got to tell me whether. Let me redefine this precondition violation condition a little bit. Okay, what if I say, okay. So we talk about the void method here. Okay. Increments By the way, so you should really remind yourself, maximum is 3. The minimum is 0, okay? So now I know that I should really encode some precondition condition over here, and then I can throw the exception over here. Otherwise, I can do counter plus plus. So now I'm going to suggest a precondition violation. Some precondition condition over here. Let me suggest. What if I say this? Counter is larger than the maximum. Okay? What's going to happen here? Do you think this precondition is good enough, just as good as before? Or this precondition is not so great, or it's better? Yes?
It's not as good because you want to increment, you can't be starting at the maximum value.
Exactly. Okay, that's exactly correct. Let me try to maybe rephrase that in a few steps, okay? You are not always given the perfect preconditions to start with. You are supposed to be the one who come up with the precondition. Once you got one there, you should always try to challenge yourself. Can there be any missing cases over there which my precondition is going to overlook? In this case, yes. So if you really got a precondition like this, you should really be able to realize yourself it's not good enough. Okay, I'll show you how you can do that. Okay, so now let's think about this. One way to think about it is a little bit more logical. You have taken 1090 already, right? The math course, right? 1090 logic, okay? Very simple logic, very simple. Let's try to understand the code a little bit. We know that the meaning for if then else is if I can ever get to the else part, what does that mean? That means the condition over here is simply not true, okay? Or it's the logical negation of the condition, right? So now I know that reaching this point means, okay, it's going to be a logical negation, but for negation in Java, it's an exclamation mark. It is not the case that counter is larger than max, okay? And we know that it is equivalent to counter smaller than or equal to max, right? So now this means this is the condition under which I may increment the value of the counter. But as you said before, in this case, it does include the possibility of trying to increment the counter when it is equal to maximum, logically speaking, right? You can see that over here, you can see the condition over here. I'll just highlight that for you. You can see over here, you do have the equal sign over there. That tells you when you're trying to increment, it is possible there would be a scenario where the counter is exactly equal to maximum, and then it's going to equal, and then do the increments, in which case it will go above the maximum, and this violates the requirements. Another way to see it, let's say over here. Oops. Another way to see it would be, let's say we have, let me use a different color. So let's say we are at this point over here. Right before we try to check that if condition, right before that. So now, if I say assume, let's say assume or say, the current counter value is currently just the maximum, currently. That's one possible case, right? If it is the maximum, that means we can replace the counter over here by maximum. So now, maximum larger than maximum, false, which means you have no chance to throw the input, the precondition violation exception, right? So that's actually two ways to see why this precondition is not good enough. If you're not so comfortable with logic, you can just think, brainstorm in your mind, what can be the input value I can try, so that the input value should have triggered some illegal argument exception, but it does not, right? So that's how you see it. Any question about this? It's just an aside to see how you can judge whether your precondition is good enough or not. Of course, this example here is very trivial, I would say, but hopefully that illustrates the point. You should always challenge yourself whether your precondition is good enough. Okay? It's not easy. Of course, it's not easy. Okay, so that's about increments, and similarly for decrements, we're going to have to say if the current value is the minimum. In that case, we're going to throw the precondition violation to say, no, you cannot do it because you cannot decrement the counter value because the counter value is already at its minimum, so you cannot decrement any further. So these are the only two methods we have in this small example, increments or decrements. And one point you should really try to observe. The way we actually figure out what the precondition should be is somehow with respect to the requirements, right? Because the requirement says that the counter value should be between the minimum, which is 0, and the maximum, which is 3. In this case, we kind of work backwards to see what the preconditions should be, right? That's actually quite common when you try to develop your classes. Okay, okay, let's go on. Okay, so we got two mutator methods, and you may violate precondition in two possible ways. Either the counter value is too large or it's too small. Okay, so you can, yeah. Okay, so now, let's say that's the programs we have done. Okay, we have programmed the counter class. How do we actually test that, right? How do we test our program? Let's say you don't know about JUnits. How would you test it? I would say without learning JUnits, the best thing you can do is really by somehow interacting with the console. I'll show you what I really mean. Okay. Guys at the back, could you please stop talking? It's quite distracting to every one of us. If you don't mind, thank you. I wouldn't mind if you carry on the conversation outside. That's absolutely fine, please. Thank you. Okay, so now let's see how we can test the counter class. Okay, that would be how you would do it, maybe back in your first year level courses before you learn about JUnits. I'll just show you very quickly. Okay, once you get an idea for the first one, the other two will be quite straightforward. Okay, so now let me just go back to Eclipse, and I would like to actually import a new package, new projects. So the one you should download is testing utility classes. Okay, that's the archive file you should download. Okay, let me just go to Eclipse over here. Let me just close everything from the previous one. Okay. Okay, let me now just import a new one. File, import, and then existing projects, next. And then I want to select archive file and browse. And then you can choose testing utility classes and then say open. Okay, so there's only one project to look at, only one, and say finish. Okay, it's called example testing utility classes. That's the one. If you expand that, so there are 3 packages over there. Okay, don't worry, I will walk you through all the 3. So first of all, let's go, well, somehow I just named them according to my personal preference, but I think it's a reasonable naming of the packages. First of all, I have a package called implementations. So implementation simply means some code for the counter. If I go into it, you will see I have a class called counter. You will see exactly the code I just explained to you in the slides. We got three attributes, we got 2 methods with the proper precondition. Okay? Now, let me just go to the other 2. There are 2 other packages. One is called console testers. Console tests. So these are the tests you would have written without learning JUnits. I want to show you that first. It's very straightforward, but we do want to see what's the limitation of that. And then we go to the 3rd package called tests, where I show you how you can write test cases in JUnits. Okay, so these are the 3 packages. So if you go into console testers, you can see I got console tester 1, console tester 2. Okay, let's see how each one of them will work. They work in a very similar way. But you can see in some way we are repeating the stuff quite in a bad way. Okay, okay, let's read the console tester over here. It's very easy, only a few lines. First of all, we have a main method over here, Whenever, if a Java class has a main method, that means the execution should start from here. So that's an entry point of execution for main method. That's what the main method means. Let's see, it only does 3 lines over there, only 3. What does it do? First of all, it prints out the initial value for the counter. So you can see line number 8, counter the value. We know that it should be 0. That's what we expect. If the program really produces counter the value as 0 as well, so the actual output matches the expected output, then that means we are good. If they don't match, then we are in trouble. Okay? Line number 9, we simply kind of document what we are trying to do. We are trying to decrement the counter. Line number 10, we go ahead and do it. When we say counter the decrements, what do you expect to see? Anyone? Well, you can see that's a test case. That's one single test. So every test should have some expected behavior of your program. We want to see if the program really behaves as we expect. Now in this case, how do we expect the program to behave when we try to execute line number 10? Anyone? Well, at line number 10, what's the value for the counter? 0, right? Well, you're trying to decrement when it's 0. In that case, you will go to the if branch, right? And what's going to happen? Exactly. So that'll be illegal argument exception. Exactly. Very good. In that case, so what we really expect the program to behave is to throw you some illegal argument exception because you did not satisfy the precondition for decrements. That's the correct behavior. That's what we expect. Let's see. How do we know? Well, if you want to know it, run the program, observe with your eyes on the console. Why don't we try to do that? Okay, if you simply try to execute that, you will see that we do have some illegal argument exception. So since like for this particular scenario, our program is working okay for that particular scenario. Okay, let's see just one more. Okay, just get more idea. Let's just to be clean, because we already got an exception thrown from this line, we cannot really continue from this method anymore. Let's just create another one. Let's say we have counter tester number 2. In this case, we are testing another scenario. You can see over here, I say counter the increment 3 times, 0 to 1, 1 to 2, 2 to 3. And then I try to do in line number 13, I try to increment. Right? You can see it's a testing of the perspective of my program. In this case, what should be the correct behavior? The question, if I try to execute this code over here, all the way to line number 13, right? Let's say I try to do that. So what would be the correct behavior? Illegal argument exception, right? So that should be from the increments because the current value is already maximum, so you cannot do it. Very good. That's what we expect. Okay, if you do that, okay, according to my eyes over there, it seems okay because we do throw some exception from there and it seems to be fine. Okay, so that's the very naive way of doing testing. I think that maybe your previous testing experience can be more or less similar to this. You print out something to the console, you simply see what's that value that's output to the console and to see if they match your expectation or not. That's more or less what you have done that before JUnits. So now, we would like to understand why this particular way of doing testing is not so great. First of all, you can see that for every scenario I would like to test, I need to create a separate, like a main method, just for cleanness. I gotta create a separate one. Even worse, how do I know if the actual output is the same as my expected output? How do I compare? With my eyes, right? Which means I need to look at the computer 2 times in this case. What if I got 100 scenarios to test? I need to run similar main methods for 100 times, compare the outputs for 100 times. So every time you gotta do something manually, that's not a good sign. We would like to automate this process, okay? That's kind of the rationale behind why this way of testing is definitely not good for any realistically sized projects. We really want to automate the way you run the test cases. Okay? You still have to write the test cases yourself, but you write it in a way so that every time you want to rerun them, you can just click the button and then you can tell you the result. You don't have to use your eyes to really compare. That's my point. Any questions just about the console testers? Okay. If you're okay with that, so let's now go back to the slides. Okay, we have seen the counter tester 1 and 2 already. Okay, so that's kind of, you can read the slides, right? Okay. So now, first of all, tell me something. I only tested 2 scenarios over there. Do you think they are sufficient for arguing that my counter is really correct? Are they sufficient? No, right? How many possible scenarios might there be for my counter? Have you guys taken 2001 already, the Introduction to Theory of Computation? This might be a very good preview of that. Okay, very, very short. Okay, I want to give you some idea, because every time you want to know about roughly how many test cases you will need for testing your software, you have to know where can the attribute values go, right? I'll just for this particular one, give you some idea. Okay, I'm going to use a different paper here to show you. Okay, so let me say I want to add a page below. Okay, so now, so let's see, what about, I would say, a lifetime of a counter? Okay, that's what I want to do. First of all, again, I know the minimum is 0. The maximum is 1. Oh, sorry, not 1, 3. Beg your pardon. Okay, so now so how many possible values are there for the counter? 4. 0, 1, 2, 3, right? I'm going to say each one of them is called so-called states. Don't worry too much if you're not feeling so comfortable about this term. You will learn about states in 2001. But for now, state simply means the attribute value. It simply means that. Okay? So we have 4 possible states. State number 1, the counter can be equal to 0. So that's one possible state. And also the counter can be equal to 1. Also the counter can be equal to 2. Or the counter can be equal to 3. Okay, so we got 4 possible states. And initially we know that the counter starts with the value being 0. That's initially. Okay, so now we want to know how we can make transitions between these states. Every time when we make a transition between states, let's say from counter value 0 to counter number 1, counter value 1, how do we do that? We do increments, right, in this case. Or how do you go from counter value 3 to counter value 2? Decrements, right? Similar idea. Okay? So now let's see how we can draw the diagram very quickly, and you will see. So from 0 to 1, we simply do an increments. And from 1 to 0, you do a decrements. So here, 1 to 2, you do an increments. 2 to 3, you do an increments. So 2 to 1, you do decrements. 3 to 2, you also do decrements. Have I missed anything? So basically, for every state, you can choose to do any of the methods you support. In this case, either increments or decrements, right? Did I miss anything in the diagram? What about in counter 0? Yes.
There's also the one where you attach
Exactly, that's possible, right? Yeah, very good. So in your 2001, that will they will teach you that you also have to consider those. In this case, let me just draw something like here. There's something so-called a dead states. Dead state simply means it's some illegal state you have entered. In that case, your program should just terminate because something has gone wrong. In this case, you can go to the dead state by two possible ways. You can either say, I'm in counter 0, and I'm trying to do decrements. Once you get there, that's it, game over. Okay? Or you can go from 3 to the dead states by doing increments. Okay, so now, how do we know how many test cases we can have. Basically, theoretically speaking, to really know how many, to really have the complete set of test cases, think about how many paths there are in this kind of graph. Okay, I'll give you one example. For example, one test, we're going to use highlight. One test case can be, I simply say I start with 0, increments, decrements, and then increments and increments. That's one possible case, right? That's like a path. Or I can do, let me just do one more. I can say I start with this, and then I try to do that. That's another case. How many are there? If you want to figure out the number of paths in this simple so-called state machine, how many paths are there? Who can give me a number? I'll write down the question on the paper here, and you tell me a number. Oh, give me one moment. Question is, how many tests or paths are there? Somebody says 64, something like that. That's okay. I can tell you it's way more than that. Any other? Yes. It's infinite, exactly. I kind of gave you a hint for the first path I did. You see, I did this, and this, right? But for how many times you can go back and forth using increment and decrements, it's completely up to you, right? So the idea is infinite. Infinite, first of all. Why? For example, I can give you an incredibly long path. I can say, start from here, 1, 2, 1, 2, 1, 2, 1, 2, and then 1. That's another path, right? You can see it really, the number of times I go back and forth is completely up to me. So if you only talk about in theory, how many tests do you need to really cover the entire possible ways for this kind of value? Infinite. Realistically, would you do infinite number of test cases? Of course not. You don't have that time. You got other courses to worry about, not just 2030, right? Also, we don't have the resources to mark your test cases, right? So now, we want to be a little bit more strategic. How you test your software is not really the focus for this course. If you're really interested in that, there's a 4,000 level called software engineering testing. So they will talk about the various kind of strategies. But for now, I just want to mention that for this particular case over here, I would say 8 will be enough. Okay? For example, I can say, I'll just use a different color here. Basically, I'm going to focus on what's the states I can reach. I can reach different states over here. So the first one is, I can say, if I'm encounter value being equal to 0, I will try decrements, I will try increments. Yeah, so these are 2 cases already. If I am encounter value being 1, I can either do increments or I can do decrements. That's another 2, right? So I'm trying to just cover all the transitions, the arrows. 1 or 2, and then 1 or 2. So I got 8. Okay? So this is just one small example to show you. Another strategy for you is you should always think about boundary values. Okay? Boundary values. So typically, the trickiest case for you to get right are the boundary values. Okay, that's something I want you to keep in mind too. Okay, so just an aside, how you can come up with the test cases. Okay, if you go back, so we got 8. So it's also summarized in the table. So what other test cases can you think of? Well, in theory, you got 8. You got 8 over here, right? So for each particular counter value, 0, 1, 2, 3, you can do either increments or decrements. And you should have some corresponding expected behavior for doing increments or decrements. Okay. So now remember we only did 2 counter tester. So that means we need to add 6 more counter tester classes. Counter tester 3, 4, 5, up to 8. Now you can see that it's not so convenient, right? Well, I mean, defining that is okay, but every time if you want to check all the 8 tests, you gotta use a mouse click 8 times to say run this as Java application, run it, and see the output on the console. Do another one and see it. And let's say 10 minutes later, I say, Jackie, run the test again. You can do everything by using 8 mouse clicks again, right? It's really tedious, really error prone. We don't want this. We really want, well, the strategy, the way we come up with the test cases, the strategy is okay, but just the way we write the test cases and the way we run them is not so satisfactory. We don't want any manual work when we do the running of the test cases. That's why we need JUnits. Okay? Okay, so you can just run through these slides. It's exactly what I just mentioned. So now let's see. Why JUnits? Okay? So we want to automate the testing of the correctness. So I'll also mention very briefly about correctness. You will learn about correctness maybe later on in 3311 and later courses. Okay? Correctness. So there are 2 notions you should be aware of. One is called the correctness of your code. Usually when we judge a code, there are 2 perspectives we can try to judge. Either it's correctness or efficiency. Efficiency is like how fast you can solve a problem. Okay? Either correctness or efficiency. Which one do you think that's more important? Or let me put it another way. If I give you a piece of code which is correct but not so fast, that's version number 1. Version number 2. I give you a code which runs extremely fast, but doesn't do quite what I ask you to do. Version 1, version 2. Version 1, right? Well, let's say if I give you an array, we haven't talked about array yet. If I give you a sequence of numbers, they are randomly distributed. I want you to sort them. Okay? So now you actually if I simply gave you an algorithm like a Java code that doesn't run so fast, but still does the job. Compare with if you simply just print out hello world. Wow, that's very fast. Just print out hello world. But does it really do anything useful? No, no. So my point is, for this course here, don't worry about efficiency. We'll talk about some notation regarding efficiency later, but efficiency is not really what you need to worry about. With today's machine, your code cannot be that slow, right? Okay, correctness. So now, we agree that the correctness is more important. So now, what does it really mean for our code to be correct? If you really want to do formally, you have to apply what you learned from 1090 to do a mathematical proof. That's the most rigorous way for proving that your code is correct. But we don't want to go there. It's too labor intensive, right? We don't want to go there. Instead, correctness simply means, let me just write it down here. Correctness simply means my code is correct. I'll put it in double quotes because there's not really 100% correctness because we're not trying to do any mathematical proof. Okay? I would say my code is correct if, to my best knowledge, all scenarios have been tested and passed. Okay, there's a little bit looser definition of correctness, which means depending on how well you have developed your test cases. Let's say for the counter example, if I give you just the 8 cases that I just talked about in the table, I would say that's reasonably good. Okay? On the other hand, let's say if your test cases only does the counter number 1, counter tester 1, and counter tester 2, only 2 cases, I don't think your level of correctness is really sufficient enough because you just don't have enough test cases, right? So for JUnits, it's a very good framework for you to add as many test cases as you find necessary. You should really add as many as you can. Okay? You can see for lab number 1, we were very nice to you. We gave you all the test cases already, right? But maybe later on, we will want you to really write the test cases yourself. you will be the one to convince that you really have developed enough test cases. And that's also what you're going to do later on. You know, this something called a software, usually they got software engineering position in the industry, or they got software engineering testing or tester position, which means your only job is to find bugs in other people's code, which is quite important, okay? So how to be able to do testing of somebody else's code or your code, that's a very crucial skill we would like you to learn. Okay, okay, let's move on. So now we want to automate the testing of the correctness, and correctness here is depending on how many test cases you have got, okay? Okay, so once you have got the test cases, like the diagram I drew, you can translate them into JUnits. I'll show you how you can do it. It's very easy. Okay, let's just go through some concept. Okay, so in some way, the JUnit test is, why don't I show you something very quickly? Okay, because in my section I talk about the notion between clients and supplier. I'm not sure if Matthew talked about it. I'll just review that very quickly. I'll write a JUnit test case on the paper right away, and then let's get some idea clear, and then we can do some coding on Eclipse if we have time. Okay. Okay. Now let's do this. Let's add a new page below. Okay. So now, first of all, let's put our counter class over here. Let's draw the sketched idea. It's not really complete. Okay, we know that we got minimum, we got maximum, we also got counter value, which is in attributes. We also got increments, which is a method, has some definition here. We also got decrements. So this is one class. So now, let's say our job is to define JUnit tests for that. But what does it really mean? We mean that we're going to use JUnit framework to create different use cases for your counter. Okay, I'll write it down. JUnit tests are use cases. Of counter. So when I say use cases, I simply means a different case of different scenarios of using this particular counter, right? As I said before, you should have at least 8 in order to be complete. Okay, let's just have one, and then let's see clearly what's going on over there. Okay, so we're gonna create another class in JUnits. I'll show you how to do that in Eclipse in just a moment. So we're gonna have class. Let's call the test counter. It's just an ordinary class, okay? And now every scenario that we're going to test is going to be encoded within a method, okay? So which means this particular method, if you execute it, that means it's going to run automatically one particular scenario and compare the expected output with the actual output, okay? Let me show you how that looks like. So now, first of all, it is really important that for every method that's going to be treated as a test case, you have to say add and test. Okay, that's very important. That's a tag you must put always. And then you can define your method. Let me use blue over here. Let's say it's always a mutator. So let's say we'll say test. I'll say test 1. Okay. Let's draw the boundary over here, and let's be clear what's going on. Okay, we got two different classes. Okay, so now basically, in the JUnit tester, we're going to make use of counter. We're going to use it just like what a normal user would do. Okay, so now I'd like to clarify some term over here. I think that'll be if you read about the textbook, which is a PDF, you will see they talk about clients versus supplier. So we have exactly that kind of relation over here. I'll show that to you. So this is the supplier. Supplier means it is a class that provides certain service to you. In this case, it provides the different utilities for counter. That's a supplier. And you can think about JUnit tester is like a client. And this client over here is going to try your products from the supplier in various different ways. In this case, let's try one way. What we can do is this. We can say integer v for value, let's say, is assigned to counter because it's static, right? So dot counter. Okay, we're simply getting the initial value for the counter. We want to double check it really starts with 0. Okay, that's the first test case. And now, how can I say that, okay, now for this method here, it successfully get the counter value, initial value for me. Now I want to say if the value is really equal to 0 as I expected, I'm okay. Otherwise, I should really signal certain error. So when we say we want to signal certain error in JUnits, we are trying to do some assertion. Okay? So there are basically two assertion methods that are most commonly used. I'm going to show you one of them. Okay? So I can write something like this. I can say assert dot assert true. So I'm actually going to pass some Boolean expression for this particular method call. So if this Boolean condition happens to be true, I'm okay. If evaluate to false, that means something is going wrong. Okay? So now, because I'm expecting the initial counter value v to be 0, I can simply put v equals 0. I can simply put that. If the counter has been implemented correctly, then this will be true. Then we are fine. On the other hand, we can try that in the code in just a moment. If I simply say initial value, if I simply say that's 3, in this case, what will return from over here will be 3. So v will be 3. So 3 equals 0, false. So that means this assertion here will fail. So this test case over here is considered as a failure. And when we generate the test report, you don't have to generate. Eclipse will do that for you. It's going to generate some report. It's going to tell you, well, for this particular method here, you have some assertion failure, okay? Because your counter class is not behaving as expected. Okay? Any question about this simple sketch over here before I move on? Maybe I can do some test on Eclipse with you together. Questions? No? We're going? Good. We got about 10 minutes. Okay, we're doing pretty well. That's good. Okay, so now let's close these over here. Okay, you already got the test counter.java in your code. That one actually got some test cases already, but I would like to show you how you can do it from scratch. So let's just say right click on that, a new class, test counter 2. Okay, it can be any class you like to use. Oh, beg your pardon, let me do it again. When you want to create a new class, the procedure is slightly different. If you right click on the package over here, it will say new. Rather than class, you're going to say JUnit test case. That's a different bit. Okay? If you say JUnit test case, and make sure you choose the new JUnit 4 test. The procedure is documented on the slides. You can go over them. You got to make sure you choose JUnit 4. Let's give a name. You can say test counter 2. Okay, and then you can say finish. By choosing that to be a JUnit test case, you can see it does some import for you automatically. You don't have to worry about them. Of course, you don't have to memorize them. As long as you follow the procedure, they will be there. They simply just import the assertions that I just used. Okay, let's try something very quickly. I will talk about this fail maybe next time. So for today, let me just do something very simple. You can also do some exercises too. Oh, one thing to note, the tag you put, I believe I put lowercase on my iPad. So just to really avoid confusion to you, it should be uppercase. So it should be uppercase. Okay, it's case sensitive. Okay, yeah, I kind of forgot. Okay, let's go back to Eclipse and let's do some case very quickly, and we'll continue next time. Not yet. Okay, we got 5 minutes. Okay, so now let's say we have a test. Let's give it a little bit more meaningful name. Let's say test. Let's say 2 increments, which means I'm going to increment my counter for 2 times. So first of all, I can say we first make sure the initial value of counter is 0, which is the minimum. Let's try to write this first. Okay? So there are different ways you can write it. Let me write in the most compact way for you. Okay? So you don't need any intermediate variables. You can simply say assert true. Okay? You can simply say assert true over here. And now you can see you need to pass a condition, a Boolean condition. Of course, I can cheat. I can say just true. Let's try that. If I simply pass true, well, what's going to happen? How do we run the test cases? Go back to your package explorer. Make sure you save the file, of course. If you go back, if you right-click on this test class, test counter 2, and you can say that run as JUnit test. You're going to see something is running. Green. It tells me that currently I got only one test method, which is test 2 increments, and there was no assertion failure. But somehow it was trivial because I just cheated by saying true, right? On the other hand, how can I fail that? If I simply say false, that's also to fail trivially, right? If I do that, I can just rerun the test cases. Right? I just failed because I passed false. Okay? So now let's do something more meaningful. Okay. Now I want to check the initial value. I can say counter dot value equals counter dot minimum. That's kind of our expectation. Now we're saying that we're expecting the initial value to be just the minimum 0. If it is, then we're okay. If it is not, then we are not okay. Let me do one more thing for you. The left-hand side of this, which is this. The left-hand side of this is the actual value. The right-hand side of the comparison, which is this, that's the expected value. They should match. Okay? That's kind of the idea. Okay? Let's do one more. Or let's run it. And then you can right-click and say run as JUnit test. Okay? That's fine. What about I do 2 increments? So now, let's say I can say counter dot increments counter dot increments. In this case, I can say, why don't you try to think about what you should write? So what now? What should be the expected value? 2, exactly. So you can just write something very quickly on your computer. I'm going to write it 2. Okay? You can see somehow it's not too bad. You just compare what's expected with what's actually produced and make sure they match. If they don't match, you got an assertion failure. Assert true counter dot value equals 2. Okay? And now if I try that, right? Okay, you pass. Okay? Any question about this? Okay, I hope the JUnit idea was not too bad, right? So somehow I kind of talk about why we need it, because that's quite important for you to know, rather than you just learn whatever we told you to learn, right? That's not very good. Okay. Okay. Let me see what else. Let me just mention a few more points. I'm going to finish this slides over here, and then we'll continue from Wednesday. Okay, let me finish this slide quickly. So now for the JUnit test case, so you can either try to use the method in a legal way, right? We try to increment we try to call the increment 2 times, which is allowed, and then we'll simply try to see if the result, for example, counter value is expected, or it will be failure if it's not the case. Or this would be something I need to spend a little bit more time next time. You can also try to use the code in an illegal way, which means we expect some precondition violation to be triggered, in which case the test case will be considered as a success if the precondition violation occurs. It would be considered as a failure if that doesn't occur, right? Kind of like a flip it around in this way. Okay? So that's something I will need to show you next time. But let me just finish the slides. Okay, exactly what I said. Okay, so the slides are available on the website, and also the code is there. So give it a try, go through the slides, and then we'll continue from there on Wednesday. I'll send you an email when the recording is available. Okay. Thank you.